Alright, now trigonometric inverses and their graphs. Trigonometric inverses are just the usual stuff. Okay, so if we have sine of x, the trigonometric inverse is going to be sine inverse of x, or arc sine of x. Okay, and you do repeat this pattern over for each one. Alright, so I don't know if you see a pattern here or not, but whenever you're doing the inverse, obviously you're going to be rewriting it as the inverse with the inverse notation, which is to the -1 power. Now, sometimes you can use that in graphing calculators, and sometimes you can't. So in Desmos, we have to use the old school arc ones, and basically right now in Trig, you guys are just going to be worrying about arc, sine, cosine, and tangent. Okay, but this is just all the inverses and everything that you need to solve. Now, this also helps when you're solving, because if you're going from a ratio, and I'm kind of getting off topic, but I do want to talk about it. If you're going from a ratio over here, and you want to find the angle, this is what you do over here. So if you want to find the ratio, stay on the left. If you want to find the angle, go to the right side and do the inverse, okay? Okay, now if you remember when we were talking about inverses, you can switch the domain and range. That's why the axes have all of a sudden switched, because when we're graphing the inverses, you need to worry about that. Okay, so in my really light green, apparently, here we go, that's a better color. Arc cosine of x is going to have a different range and everything. Now, in order to be truly a function, it can only start here and stop here, or vice versa, however you want to view it. Okay? And its y-intercept is definitely going to be through pi halves, okay, and it's going to start at 1, 0 and go all the way up to -1, pi. Or if you see it the other way, it's going to start at -1, pi and go right down to 1, 0. Okay, this is the only way it can stay a function. If it goes any more, it's going to be non-function because of the not passing the vertical line test. Okay? Alright, so that's the arc cosine inverse. Now this also explains principal values as to why principal values for cosine only go from 0 to pi. Okay, so that's another way of explaining why when we do inverses on your calculators that you're only going to get these values, because repeating it over again would violate the function rule. Okay, alright, now arc sine is going to be around 0, and it's going to start at -1 and negative pi halves and go up to 1, pi halves. Okay, and this also explains why sine is also, or arc sine, when you do arc sine on your calculator or sine inverse, you're going to find that you have to add some values to it. Okay, so that also explains it too, because in the calculator it's only thinking along these function rules or these function lines, so you manually have to add those together. Okay, now tangent, I love how all these colors turn out to be the lightest colors. That's funny. Okay, now tangent is obviously going to, its domain and range are flipped. Okay, but when you flip the domain and range, you have to pay attention to the fact now that the range is from negative pi halves to pi halves, and the range is all real numbers. Okay. Alright, now tangent, we also do the same thing. We go from pi halves to pi halves, negative pi halves to pi halves in the answers too. So this doesn't explain it. Well, this does, because this is the range you're going from this negative pi halves up to this pi halves. So this actually explains it. It's not as nice and neat, and it actually goes on forever in both directions, but it's actually really kind of cool how it works and explains why your calculators only give you the principal values. Okay. Alright, now if you graph them all on top of each other, you're going to get a non-awesome mess. But it's kind of cool, because if you graph the cosine inverse and the sine inverse at the same time, you get kind of a nice symmetry to it. So, alright, that is it for the inverses functions and their graphs. Have a great day.